Hello everyone, and I welcome you all for a 2 weeks online internship program on demystifying IoT security for digital world. Myself, Santosh Rathod, Assistant Professor from Department of Information Technology. In this video, we will be dealing with the comparison of the embedded boards. Till now, we have gone through the different embedded boards, the Arduino, the ESP8266 and the Raspberry Pi. So here we will see the comparison of the different embedded boards here. To select a board for the development of your project, it's a tough task in deciding what all the requirements are there and then how to execute that one and which board to go for. So you might be thinking that which board is best for you. As always, it all depends. When taking into consideration, we take the Raspberry Pi, the most powerful and versatile platform. For education purposes, it has the most resources and it's perfect for projects requiring a powerful Linux computer or gateway. It's also the easiest platform to get started by. Arduino is the best choice for real-time input-output control, battery-powered projects, and it also comes with good materials for STEM education. You may not even have to choose between Raspberry Pi and Arduino as both can be combined with an Arduino board being connected to a Raspberry Pi board over a UART connection. Whenever you think about adding Wi-Fi or Bluetooth connectivity to your project, the ESP8266 or the ESP32 board are the obvious, cost-effective choices. The downside is that the platform may be better suited for people with a higher knowledge of electronics and programming. So now, further, we will see the comparison of the different boards. So here we have taken into consideration the Raspberry Pi Pico, the Arduino Uno, the Node MCU, or the ESP8266 and the ESP32. Since we have already dealt with the Raspberry Pi, the latest version 4, and the Arduino Uno and the Node MCU ESP8266, here we have also taken into consideration the ESP32. The ESP32 is the latest add-on to the ESP8266 community. So when talking about the microcontroller, the Raspberry Pi has an RP240 2040 microcontroller, then the Arduino Uno has an Atmega 328P microcontroller, then Node MCU has the ESP8266 as a microcontroller and ESP32 has the ESP32 microcontroller. And talking about the core, the Raspberry Pi has a dual core, the Arduino Uno has a single core, the Node MCU ESP8266 has a single core and the ESP32 with an add-on has a dual core. Talking about the architecture, Raspberry Pi has a 32-bit ARM Cortex M0 Plus architecture. The Arduino Uno has an 8-bit RISC architecture. The Node MCU has a 32-bit LX106 architecture, and the ESP32 has a 32-bit LX6 with 600 DMIPS architecture. Talking about the clock speed, Raspberry supports up to 133 MHz. The Arduino Uno has 16 MHz. The ESP8266 has up to 160 MHz and the ESP32 up to 240 MHz. Operating voltage, Raspberry Pi operates at 3.3 volt, the Arduino Uno operates at 5 volt, and the rest ESP8266 and the ESP32 operates at 3.3 volt. The general purpose input output voltage, except the Arduino Uno, all the three boards have the general purpose output voltage of 3.3 volt and the Arduino Uno has a 5 volt. Next, coming up with the digital pins, the ESP32 supports 36 pin, the Node MCU supports 16, the Arduino Uno 14, and the Raspberry Pi 26 pin. When talking about the pulse width modulation pin, the Raspberry Pi supports 16, the Arduino Uno 6, the ESP8 to 616, and the ESP32 supports 32 pins. Analog pins, Raspberry Pi has 3, the Arduino 6, the Node MCU has 1 analog pin, and the ESP32 has 15 analog pins. Now talking about the serial peripheral interface, the inter-integrated circuit, and the UART, Raspberry Pi Pico has as listed here, and the Arduino Uno with 1, 1, and 1. Then the Node MCU supports 2 SPI, 1 inter-integrated circuit, then 2 UART connections, and then 2 I2S. Then the ESP32 supports 4, 2, 2, and 2. Then about the Raspberry Pi Pico, with regards to the Wi-Fi, it doesn't support Wi-Fi, even same as for the Arduino Uno. Even the Node MCU supports the Wi-Fi, and the ESP32 has a Wi-Fi module. With the Bluetooth, except the ESP32, no other board has the Bluetooth module. Now, with regards to the programming language, the Raspberry Pi supports the MicroPython, C and C++. The Arduino Uno board supports the Arduino IDE, C or the C++. The Node MCU has an Arduino IDE with the C++ or the MicroPython and the JavaScript, and the ESP32 has an Arduino IDE, C++, and the MicroPython. Onboard programming LEDs, Raspberry Pi Pico model, the general purpose pin 25 pin, Arduino Uno, the digital 13 pin, the Node MCU D0 pin, digital 0 pin, and ESP32 D2 pin. The flash memory, Raspberry Pi supports 2 MB, the Arduino Uno 32 KB, then the Node MCU has a 4 MB, and the ESP32 4 MB. Now about the RAM, Raspberry Pi has a 264 KB of RAM, Arduino Uno has a 264 KB of RAM, Node MCU has 128 KB, and the ESP32 520 KB. Then the EEPROM, Raspberry Pi doesn't support. The Arduino Uno has 1 KB, Node MCU 520 bits, and the ESP32 is not supported. Then about the built-in sensor, Raspberry Pi has a temperature sensor. Arduino Uno, it doesn't support the built-in sensor. The Node MCU has no built-in sensor, and the ESP32 has a touch temperature Hall effect sensor. Programming language is supported. As we already discussed, the MicroPython C++ for the Raspberry Pi, for Arduino Uno, Arduino IDE or the C++, and for Node MCU, MicroPython, JavaScript, C++, and for ESP32, we have the MicroPython and C and C++. We have already discussed with the onboard programming LED as well, the flash memory, the RAM, and the EEPROM. I hope this video was helpful to you for comparing the different embedded boards. Thank you everyone for your patience listening.